Hello class, this is going to be your instructions for your first lab. So this is for 4600. It's a simple lab on how to work with the fork and weight system calls. So we're not going to work with exec, at least not yet. So this is going to be rundown on how we make processes from another process. So as mentioned in the lab instructions, you need to do this on a Unix system. So if you're on a Mac, you're probably good to go. If you have a Linux system already, you're already good to go. If you are on a Windows system and you don't have access to a Unix system, this is where you would want to have a virtual machine with Linux distro installed on it. So in my case, I just went with Ubuntu because that's the one I'm used to. So we can just simply begin by, let's navigate. Let me just reset this for a minute, and let's create a new folder for our lab. Let's call it Lab 1, and this is gonna be our fork and weight stuff here. So we can open a new terminal in here. So just right click in the empty space in here, and we can simply type in vi lab. Let's call it vi fork.c. And vi is a text editing program that runs in the terminal. You can just type away right now, but there we go. Now we can type like this, but we can use vi, but I personally like the other text editors that are on Ubuntu. So what I'll just do is I'll save this document here. I'll press escape:\wq. This saves the file, and now I can just open it using a text editor just here. Yeah, that's just how I create files on. This is how I create source code files on a Linux system for whatever reason. I just create it using vi, and then I just save the document and then reopen it in a text editor like this. So what we're gonna do is we're gonna work with the system calls that create a new process, primarily fork, and then we're gonna try out wait. So let's begin with typing out some code. So include Unix standard.h standard io.h sys/types.h and sys/wait.h. Alright, let's begin writing our main function. Int main. There you go. Now, we're just gonna create a process as follows. First, we need to do this. So PID_T. This is a data type that stores our process ID. We get a process ID as our return value when we call fork. So I'm gonna say PID equals fork, and then I'm gonna type in int status. That status is gonna become important in a little bit. So if the process ID is less than 0, it means we got an error. If PID is less than 0, we encountered an error while trying to fork. So we can, so here we'll just say p error fork error. There you go. Else if. Come back. So if the process ID is 0. So once it forks, now we have two processes that are running the same program. One is the parent, the other is the child. But the key difference is this. The parent will have called fork, but the child will have not. If the process ID is 0. That's the child process. So this is the child process. We're just gonna say printf hello world from the child process. There we go. Finally, else, this is gonna be now the parent process. So we can simply say we'll say hello world from the parent process. We're next gonna wait for the child process to finish running. So I'm gonna call a function called waitPID. So what I'm gonna do is call waitPID. We're gonna pass in that process ID. We're also gonna pass in the address to a status variable. So previously I wrote a status variable up here, status, and next I'll write in 0. So that is the call for waitPID. And after that, we're gonna print out that the child has finished. So printf. So when the parent executes this line, it's gonna wait for the child to finish running. And when it does, after that, it's gonna execute this line of code. So printf %d. So this is gonna be our status here, but we need to pass it into another function, which is as follows: w exit status, and it's all caps. There we go. Return 0. There we go. So we're just gonna play with this program a little bit and see how well it runs. So the command to compile this program is gcc-o. My bad. It's gcc filename.c, which is fork.c here. -o filename. Okay, I kind of messed that up. That should have been this. So there we go. I gave it the wrong name. So let me just remove that really quick. Okay, so once again, the compile command is gcc fork.c-o fork, where fork.c is the source code file and fork no file extension. That is the name of the executable. If you don't have the GCC compiler installed, you may need to install it. In the case of Ubuntu, it'll tell you what command you need to type for you to install it. So let's proceed from here. And that, okay, that just recompile it. For us to run the program, it's /fork, and there we go. It worked. So in your lab instructions, it tells you to try out the program, but you're gonna modify the program so one process prints out your name, and the other process prints out the name of your favorite TV show. So we're just gonna tweak the program a little bit. I'll leave that to you to do at your own time, but that is just part 1. Part 2, we're gonna simulate these processes doing some work. So we're gonna modify our same program as before. So for now, let's go back here and modify our code as follows. For this block of code, which is executed by the child process, we're going to simulate some work. So sleep for 2 seconds, and then child process has completed its work. Okay. Here, what we're going to do is this. We're going to have the parent process also do some work. And that is sleep 3. So we'll sleep for 3 seconds. There we go. So we're gonna save this program, and then we're gonna recompile it, and then we're gonna run it again. So child process has completed its work, and then the parent process has completed its work. So yeah, so that delay was because the two processes were sleeping. We're doing a sleep operation to simulate them doing some work. So the child process ran for 2 seconds and then said it completed its work. Meanwhile, the parent process was running for 3 seconds and then it finished its work. So one modification that I would like for you to do for part 2 is simply switch the times in which these two processes complete their work. So previously, the child process did its work for 2 seconds, the parent process did its work for 3 seconds. Now we swap the 2 times and see whether we get different output. So let's recompile that program and rerun the program. Okay, pretty simple, pretty self-explanatory. When we have the two processes finish at different times, of course it's going to be the first one that finishes first. Okay, so this is your first file that you're going to submit. I'm going to make a new file here. So clear. And I'm going to create a new file called wait. So I'm just going to type in vi wait.c escape :wq. Open that in my text editor here. Now the code is a little bit more involved here, but I'll tell you right now, we can just copy a lot of the same code from fork.c. So I'll just do that, and well, I'm gonna need to erase some of the code here. Okay, so here we're gonna need to run two processes. So the parent process is actually gonna fork twice. So there's gonna be a PID 1 and a PID 2. So here's how it's gonna work. If PID 1 is 0, that means we had encountered an error trying to fork. If PID 1 is 0, that means that is the first child process. So hello world from the first child process. And then, here's where it starts to become nested. I'm going to copy that. Well, actually, I can just copy this part here. I'll copy that and paste that in here. I'll indent that by one more level so that we're now in the parent process's code here. So it's gonna fork again. So we're gonna say PID2 equals fork. If PID2 is less than 0, that means we encountered another error. Otherwise, if that's 0, that's gonna be the second child process. So all this code that we have here, we need to put that in here. So I need to move all this code into this block here. So now, here, the parent is gonna wait for its two children to finish. So we go. So this is the parent after forking a second time. So it's gonna fork once, and then it's gonna fork again. So this code is a bit nested right now. Okay. Wait for a child to finish, but yeah, it's gonna be like that, but it's a little... But here, we need to copy-paste this code. So we need to copy-paste... We need another copy of the same code. I'll paste that here. So that's wait for the first child to finish, wait for the second child to finish. So we need to pass in PID 1 and PID 2. Wait PID has the calling process wait for a child process to finish, and we specify that by process ID. So we pass in a process ID, so it says here, we're gonna wait for the first child process to finish, and here we're gonna wait for the second child process to finish after that. Oh yeah, one other modification. We have status 1 and status 2. So you have two statuses now, so that should be status 1, and in here status 1, status 2, and in here status 2. Okay, so what this is gonna do is as follows. The parent process is gonna call fork once, and after it has successfully called fork once, the child process is gonna execute its own code. The second child process is gonna... Okay, so, as I said, first child process runs at the same time, the parent is gonna call fork again, and the second child process runs and calls its own code. After that, the two child processes are gonna run, and then they're gonna finish running. The parent process is gonna wait for the two processes in this order. It's gonna wait for the first child to finish, then the second child to finish. So let's try it out. I'm gonna compile the program by saying gcc wait.c. So /wait, and now it runs. So first child process, second child process, and then they exit in order first, then second child. Alright, so for part 3, it has you modifying the code. So one process prints your name, another process prints out your major, and another process prints out the year you expect to graduate. So this is a little bit of having a little bit of fun with this program here. But yeah, I'll have you do that in your own time. But our next step is part 4. We're gonna simulate some work here. So, we're gonna modify our program once again. So, now, we're gonna have the two child processes simulate. We're gonna have them simulate some work being done. So, we'll have the first process simulate working for 5 seconds. So sleep 5. So it's gonna work for 5 seconds. So I'm now gonna say printf first child has finished its work. I'm gonna copy this code and paste it here, but it's gonna do work for 2 seconds. And now here's the next modification. What we're going to do is we're just going to comment out these two functions. Next, we're going to use a different function here. And that function is wait. I'm going to pass in a status here, so pass in the address of status 1. So wait is a function call that's going to wait for any child process to finish, regardless of its process ID. This returns a process ID that tells us which process it was. Okay, one thing I've neglected to do is the following. If we want to tell which process was what, we should probably add in the process ID. So let's do that. So let's make another modification to these two lines of code here. PID %d, and we're gonna use a function called getPID. That's gonna have the child process process ID get added to the hello world strings here. Let's also add it to the parent process just for the sake of completion. So we'll just paste it here. So getPID, that is a function that gets the process's process ID, and we need that so we can tell which process finished first. So wait returns a process ID that we can then use to tell which process finished first. So after this, we're going to say printf child process PID %d has exited with status %d. And then we're going to pass in wait PID 1. Oh wait, I forgot to define that. So wait returns a process ID. So I'm going to have to store that in a variable. So PID t wait PID 1 equals wait status 1. There we go. Next, I need to pass in that status. So w exit status 1. There we go. So whichever child finished first, it's gonna report that by printing out that process's process ID. Then we're gonna repeat that with the second child. So this is gonna be wait PID 2 status 2, and then wait PID 2 status 2. There we go. Okay, so we're gonna now recompile this program, and then we're gonna run it again. So now it's printing out the process IDs. So notice that, okay, so it's programmed so far so that the first child process finishes. No, actually no. Check this out. The first child process runs, it seems it's doing work for 5 seconds, but the second one seems it's doing work for 2 seconds. So that means the second child process has finished its work earlier than the first one. So it's gonna, the parent process waits for a child process to finish regardless of its process ID. So because the second child process finished first, it was, of course, going to be the first to report that it's finished. And then the first child process. So the second was first and the first was second. The second child was the first to finish, and the first child was the second to finish. And we know that's the case because look, there's the process IDs. First child process finished second because that was PID 3995. And the second child finished first because that was PID 3996. There we go. Okay, so this was part 4. Add some code that simulates some work. Which process is finished first? And then that's instruction 1. Instruction 2 is replace the code for waiting for the 2 processes with the following code, where replace the code for the replacing wait PID with wait has the parent process wait for any job to finish regardless of PID. Did the order in which processes finished change? How would the order in which the parent waited for processes? So yeah, go through the instructions and follow along with the code here. And yeah, so your deliverables are as follows. For part 1, you're just gonna provide one screenshot. For part 2, you're just gonna answer the question here. When you switch the sleep times of the parent and child, did you notice a change in which process finished first? And then you provide the code for fork.c after the changes made to part 2. Part 3 is a screenshot, and part 4 is to answer this question here. When you replaced wait PID for wait, did the order in which the process finished the work change? And did the order in which the parent waited for processes change? And then the code for wait.c after you've made the changes to part 4. There is a bonus question, and that is, it turns out wait is a shorthand for another function called or the wait PID with a few specific arguments passed in. So, for 5 extra bonus points, what arguments do you need to pass in to wait PID to get the equivalent functionality of wait? I do have a little bit of a hint there. So, man is a command that you type into the Unix terminal. It opens a manual. So for example, you can type in man to get a manual page on the manual command itself. So yeah, this opens up a manual for various commands that you might be using in Unix. And press Q to quit. And PS. So PS, that reports a snapshot of the current process. Quit man ls. That is a command that lists directory content. So if, for example, I just type in ls, it gives you a list of all the files that are in my working directory. So here they are here, and here they are there. Yeah, so probably a good idea to get acquainted to the Unix terminal, especially if you've never used it before. So I'm gonna have a lot of our labs work on. I'm gonna have a lot of our labs work on a Unix system, just so you can get some familiarity with how Unix works, of course. So with that, I'm gonna leave it here, and this is gonna be your first lab assignment. All right? Okay. So that's the end of our lab discussion, and our next lab is gonna be all about pthreads. So it's an introductory program to pthreads, where we're gonna make a hello world program, and then we're gonna pass in a few extra. And okay, so in pthreads, when you create a thread, you pass in a function that you want that thread to run. We're gonna try that out next lab, okay? Right, thank you, bye.